So here's the standard Arduino screen that we know and love, and if I open the serial monitor, you can see with this running at the moment, it's collecting the data from the GPS unit, which is just scrolling through at the moment. So I've got it to spit it out on the serial port just for debugging purposes, so we can see what's going on. I'll whip off the auto scroll button here, and you can see we can go through in a little bit more detail, but essentially I am using the print function that I've constructed to get the ADXL registers. So this is just a double check on the fact that the ADXL registers configuration hasn't changed, and that it's been loaded from Flash directly into the ADXL, and you can see the ID from the ADXL here that we've got, which is a direct read. We've got some data here from the GPS unit, and now we've got the ADXL repeated. So let's just look and see what happens if I give this a bit of a thump. So if I just drop the board a couple of times, you will see some information on what's going on. So let's do the same again and take the auto scroll off so we can have a look. And here we have the same thing again. We can see that my interrupt point here, which was the big shock detected, I got a status from the interrupt. Essentially I'm looking at a mask to see what was the source of it. In this case it was a shock. We grabbed the local time at that point that it occurred. It's reading the real-time clock. We've got some bits and pieces here, well, that long, which isn't being collected at the moment because there's no satellites, but we know that because of the aerial not being close enough to the window. And then some details about what it's doing when it received the shock. So it's writing to the SD card two files, shocker text and shocker.txt. So it's, first of all, you notice that it's reading the file to see whether it exists, and if it does, it's going to append the data to the shocker.txt and tells you that it's appended. And then we do the same with raw.txt, and we append the file raw.txt. And here's the data for both those files that we've written to the SD card. So here we've got a timing point, and we've also got the scaled X, Y and Z figures, so we have an idea of what magnitude in here of shocks that we're showing. On the web page you will see that I've plotted these in Excel to give you an idea of what that looks like. And here's the raw data that the top one originated from. So here we've got the hex values of what was recorded at that moment in time. So that's the data, which is 2's complement. So we've changed those 2's complement data into something a bit more readable form, and I've expressed the negative figures. Notice that all the data has been separated by comma delimits, so that we can import that into Excel and display it how we see fit. And basically we're back round again with the GPS data, which is just a cycle round really of the different values that we can get from the GPS. If we look at here, we can see that as far as the includes concerned, we're using tiny GPS for the GPS data, we're using wire for the I2C, and we're using file system, obviously, and we've got SD.h and SPI.h associated with the SD card. Notice also that we have the Adafruit in here, SSD1306. That SSD1306 is associated with the graphics, the OLED display, which we looked at previously. So that's just an include for that. So and the rest of it is defines and various bits and pieces, which I will document a little bit later on. This is very much a work in progress, so this is subject to change. We also have a web server which is invoked when we use another interrupt pin, and that will allow us to change the settings on the device in terms of it remotely automatically connecting to the router on boot. So we can effectively connect or get this device to connect to a mobile phone or a router as an access point, and therefore access a web page to actually upload this data directly onto a web page, and then we can display it remotely. That's very much work in progress, and I'll update you as that moves on.